The environment has always changed. This seemingly innocent statement dominates YouTube videos and Reddit threads dedicated to debunking our current state of scientific knowledge about climate change. Climate change deniers love to use geology in their arguments. They cite examples of global warming from the Earth's past, or they latch onto the fact that carbon dioxide and temperature have generally been higher than they are today. And they use these facts to argue that our current state of climate crisis is nothing to worry about. Their use of geology begs the question, to what extent can we use geological examples to understand the climate crisis? To begin to answer this question, I'd like to introduce you to one of the fundamental laws of geology, the law of uniformitarianism. This principle essentially states that the fundamental natural laws governing the Earth's surface have stayed the same for the entirety of geological history. To demonstrate this, there is no better example than the ripple. A sedimentary ripple forms when water or air moves across sediment, causing that sediment to pile up in characteristic undulating peaks and troughs. Modern ripples are everywhere. I took this photo on the left on a beach a month ago. You can also find them in rivers, desert sands, and lakes. Ripples are fundamentally transient structures. The ripples you see on a beach today will not be the same as the ripples you see on a beach tomorrow. And that makes it, in my opinion, mind-blowing that the same structures of ripples can be preserved in rock for billions of years. This photo on the right is a photo of a 750 million year old sandstone, and you can still see the outlines of ripple crests pointed out with yellow arrows. These ripples have been buried, turned to stone, and then through the slow, grinding action of tectonic plates, have been uplifted to the surface where we can see them today. And despite the long, long history of this rock, we can still see a snapshot of a single moment on a single day at a time before animals and plants had even evolved. So in that way, the ripple is the perfect example of uniformitarianism. When water moves over sediment, that sediment reacts in the same predictable way, regardless of whether it happened today or hundreds of millions of years ago. So in that way, the present is the key to the past, and the past is the key to the present. Now, you might be thinking, Charlotte, this is a really cute example, but this is a talk about the climate. And you might be questioning, does this apply to the larger scale processes on Earth too? Well, in some ways, uniformitarianism holds up. Because the laws of physics have stayed the same, the individual processes happening at the Earth's surface have stayed the same too, such as greenhouse gases trapping heat. Because of this, scientists can take past examples of climate change from the ancient record, and they can use them as a sort of natural laboratory to inform our current understanding of the climate. There are many very useful examples of past climate change, but one of the most pertinent is the Paleocene-Eocene thermal maximum. 56 million years ago, the mass release of volcanic carbon dioxide, as well as the emission of methane from the melting and release of ice, resulted in a temperature change of between 5 and 8 degrees Celsius, because the addition of those greenhouse gases caused the temperature to warm. Scientists can use the chemistry and structure of rock to deduce how the planet responded, with ocean acidification, the extinction of many marine sediment-dwelling organisms, and the radical redistribution of plants and animals on land. We can also look at more extreme examples, such as the largest mass extinction in the whole of Earth's history, the end Permian. 252 million years ago, there was again a huge emission of volcanic CO2, but this time, temperatures warmed by over 10 degrees Celsius. That is an unimaginable amount of climate change. And the result? The extinction of over 90% of species on Earth. The thing is, scientists know that there are limitations to taking these past case studies and using them to inform future predictions. The world in which these case studies happened has since then gone through huge changes in evolution, plate tectonics, and the chemistry of the oceans and the atmosphere. So even though the fundamental laws are the same, the context is different. The world in which those ripples were deposited had no animals. The world in which the first animals evolved had no terrestrial plants. And the world that we live in now is fundamentally different to a world before humans. In fact, many geoscientists are proposing that we're living through a whole new geological epoch, the Anthropocene, because humans are changing the planet so severely that it will be preserved in the geological record. For example, industrialization has caused land use to shift due to the expansion of urban environments and agriculture. We've also shifted ecosystems and started what may turn out to be the 6th major mass extinction in Earth's history. One of the most stark changes is that we've emitted carbon dioxide from fossil fuels on a mass scale, resulting in a temperature increase of over 1 degree Celsius. And this may not sound like a lot, considering the examples I've previously used, but consider that 1 degree was emitted over the course of 150 years, and the usual geological timescales for warming are hundreds of thousands to millions of years per degree of warming. We're truly shifting the planet at all scales. Even the tiny ripple, which I used as an example of uniformitarianism, may be fundamentally changing, incorporating human-produced microplastics for the first time. In many ways, we are living through an unprecedented event in Earth's history, and that means there is a right and a wrong way to use past examples. Climate scientists compare and contrast their examples and use multiple lines of evidence. The examples I showed before are only compellingly applicable to the modern day when you see their consistency with other case studies. On this graph, increasing rates of warming plot to the right, and increasing amounts of temperature change plot to the top. You can see that large, rapid temperature changes are consistently linked with mass extinctions, which plot in the top right. This is a consistent result, despite each of these case studies happening in vastly different geological contexts. By contrast, climate change deniers ignore any evidence that contradicts their theories. They simplify and they cherry pick. One of their favorite arguments is that carbon dioxide and temperature were higher in the past, and animal life thrived, so we have nothing to worry about. The underlying fact that carbon dioxide and temperature were higher is actually true. For most of the time that animals dominated the planet, both of these things were higher than the modern levels shown by horizontal blue lines. But the logical leap that climate change is therefore nothing to worry about is deeply untrue and misleading. The world in which these animals lived had no humans, no anthropogenic infrastructure, even a totally different arrangement of the continents. But most importantly, the rate of warming was slow. Each of these spikes in temperature may look fast, but it took place on geological timescales. And if you zoom in on the spike, it took place over the course of millions of years. These kind of timescales allow organisms time to evolve and adapt. So where the climate is concerned, the past is only the key to the present if we provide full context. Human timescales are the blink of an eye compared to geological ones. And this is both sobering and hopeful. Yes, we are living in an unprecedented event in Earth's history. And yes, large, rapid temperature changes are consistently linked with mass extinction. But because human timescales are so rapid, we still have time to take action and fix the climate crisis. We must stop the mass emission of fossil fuels, and we can do so by collective action, by joining together and campaigning local and national governments for green policies, by voting with our dollar for sustainable products and services, and by shifting society's accepted viewpoint back away from climate denial. If you're around somebody using oversimplified arguments from the Earth's past to justify their climate skepticism, question it. Be critical. Ask them about the context of their examples. Because there are many lessons to be learned from geology, but the most important one is this. We still have time to fix the climate crisis, but we do not have time for climate denial. Thank you so much for your time.